Chapter 7, X-ray Production, Target Interactions. The objectives for this chapter are types of target interactions, heat production, Bremster-Long radiation, characteristic radiation, and the KeV effects on radiation. Over 99.8% of kinetic energy is converted to heat. Increasing kinetic energy increases the efficiency of photon production. Because they have such high kinetic energy, incident electrons seldom transfer enough energy to the outer shells of target atoms to cause ionization. Instead, they transfer enough energy to excite the outer shell electrons to the point where they emit infrared radiation as heat. Bremster-Long interactions are named by the German word for breaking or slowing. This occurs only when the incident electrons interact with the force field of the nucleus. When the incident electron gets close to the nucleus, the powerful nuclear force field is too great for the electron to penetrate. Thus, breaking occurs and diverts the electron's course. Energy that is lost during the breaking is emitted as X-ray photons. Bremster-Long photons are the difference between entering and exiting kinetic energy of the electron. Characteristic radiation occurs only when an incident electron interacts with an inner shell electron. The incident electron must have enough energy to knock the inner shell electron from orbit, thereby ionizing the atom. The electron hole that has been created in the inner shell makes the atom unstable. Characteristic photons are the difference between binding energy of outer and inner shells between which the electron dropped. Characteristic cascade is the dropping and filling of the hole until the outer shell is missing. KeV effects on Bremster-Long and characteristic radiation. Increasing mass also increases amplitude of the emission graph. Note that there are more higher energy photons on the higher curve, as well as an increase in the number of photons seen in the increased amplitude. Each point on the higher curve represents exactly twice the number of photons in the lower curve. The generator phasing also has an effect on the emission spectrum. As the efficiency of X-ray production increases, the emission spectrum changes. As generator phasing efficiency increases, the X-ray beam increases in intensity, and there is also an increase in the average photon energy.